Hello, in our linear search we have observed the elements are compared, every element is compared until we are getting that element, and the elements are random, there is no order of the elements, and the worst case complexity is big O of n. Now, is there any better searching algorithm do you have? So, let us have a look. The algorithm that is called binary search. Why it is called binary search? Because of the whole list is divided into two different parts. Binary means 2, binary means 2, that is why the name is. The first condition of binary search is what? The elements must be sorted in an order. Okay, what is the order? The order can be ascending or the order can be descending. Now, say for example, this is an array, the elements are sorted in an in ascending order. Okay. Now, I have to search some element. Now, we will say what are the applications of by this binary search? This binary search is applied basically in secondary storage, in our databases, in our indexes. This binary search is very much helpful to search some particular element. The condition is here the element must be sorted in a particular manner, either ascending or descending. Let us have a look how we search a particular element in case of binary search. So, how we will do it? Say for example, I have a book and that book having the page numbers, and we know that all the pages are ordered in ascending order, they are arranged already. So, if I try to search a particular page, say for example, I want to read the function. So, I will first what I can do, I know the first value of this page and last value of this page number, I will can able to find out the middle page. So, I will go to the middle page. Yes, is this particular element that I am searching for, or is this particular page that I am searching for? If it is yes, yes, I will so say yes. Otherwise, if the value what I am searching for that is lesser than the middle one, then I will go to the left side. That means at the first go I can discard the half of the elements. That means if I have, say for example, a huge number of elements, say for 1 lakh element, at the first go I have divided the whole list into two different parts. I am comparing with the middle one because I know the index. So, what I will do, if the middle element is the element that we are searching for, that is okay. Otherwise, either we will go left side or right side. If we go left side, that right side element near about 50,000 elements are not in my list, I need not to search from that particular domain. Again, I will again find out the middle of this particular list, I will again search for the middle of this particular list. So, the second go, this is my target list from where I want to search, I will again find out the middle position, and if the middle position is the element whatever or element at middle position, if the element that we are searching for, that is okay. Otherwise, I will either go left side or right side. In the second go, near about, say for example, the element we are searching for that is greater than our middle element, then that must be we will search in this domain. So, this domain is discarded, near about 25,000 elements are discarded, that means I have to search for from 25,000 elements. So, this way we can divide the whole problem into two different parts, and every time we will search in a new list. So, every time we are dividing the whole problem into half. So, that is very much easy. Okay. So, let us have a look with the particular example that I have written here. Now, let us have a look, try to understand the concept. Okay. Now, in this case we have first what we will do, we will say for example, I am using two variables, one is beginning index which is 0, what is end index? The end index is 15. What is the middle index? What is the mid index? The middle will be 0 plus 15 divided by 2. So, what is that? Near about 7. This is the floor value. Okay, we are taking the floor value, and we are, say for example, the key element that we are searching for, say for example, we are searching for what value? 18 we are searching for, 18 element. Now, in the first go, the beginning is 0, end is 15, middle is 7. So, I will compare key with, is it A of mid, that means if it is this element, is it? So, middle element is 7, is it 33 is the element that we are searching for? No, we are not searching for 33. So, we will go to the which side we will go, because look here, the key element is lesser than the mid, because 33 is the mid element, lesser than this. So, in the first go I can able to, or we can able to discard, we can discard this whole part, we can able to discard, the right side part elements will be discarded. My target list is this one. So, now the beginning is will not change, beginning will be 0, and end index, the index from where we are from where to where we are searching for. So, end is what? Middle minus 1. So, middle minus 1, that means 6. So, I have to search for from 0th index to 6th index. Okay. Now, what? The sorry, this is end, and this the mid will be, what will be the mid? 0 plus 6 by 2, it is 3. So, I will compare the key element, that is 18, with our A of mid. So, what is A of mid? Mid is 3. So, 3 is what? This is 3. Here what element is there? 15. So, it is 15 is greater than my, sorry, 15 is lesser than my key element. So, it is not there. So, it must be this side. So, my new list is now this, my new list is now this one. This one is my new list, this one is my new list. So, what is my new list? So, now beginning value will be what? Mid plus 1, okay. Mid plus 1 means this is 3 plus 1, that is 4, and end will be same. I will not change the end was 6. So, I will just find the mid value, that is 4 plus 6 divided by 2. So, this is 5. Now, have a look, 5 is the next element, 5 is, I will compare with this 5 1. So, it is not, so it will have left side. So, at 4th place I will have the element. So, this way I will find the elements. So, this is very easy when the elements are huge. In cloud also, whenever the data we are trying to search for, whenever we are searching some data from the database also, this particular technique is very much helpful. Now, have a look about the algorithm of this particular case. We are trying to know now the what is the algorithm for it. Okay. Now, for this case, let us have a look. Okay. So, this is the algorithm for it. Okay. Now, I have a look, the algorithm says, if we so first what we are providing. So, we are providing few values. What are the values we are providing? We are providing few values. So, first value is the array A. A is the whole array. A is the whole array we are providing. N is what? N is what? N is the number of elements present in this particular list, and the condition is elements are sorted. And K is what? K is the element that we are searching for. This is the element we are searching for, key element. Now, begin is what? Begin value. This value is initially 0. End value is what? N minus 1, because I have considered n is what? N is the size of element. So, n is 16. So, n minus 1 is the end index. Now, until unless we will, while begin is less than equal to end, when the begin value, that means 0 is less than that particular value 50 less than equal to, we will continue this task. First task is what? Mid is begin plus end divided by 2. We are finding and its floor value. Definitely we will find out its floor value. Okay, we are finding its floor value. Now what? Now what? We will check if key is A of mid. If key value is the A of mid, then we will return If the element is middle element, then we will say yes, the element is found. Else, if the key is lesser than the mid A of mid, then we will increment the end value. End value will be mid minus 1, and else case begin value will be mid plus 1. Okay. So, if the key value is lesser than mid, then we will be these two conditions in case of if and else, and this way we will iterate and we will able to find out the element is present or not. It will return 1 if the element is found, and in no case it will not return anything. That means, by default we will consider some value, and by help of that we will able to check the case. Okay. So, what is the time complexity for this? For this, the worst case complexity for binary search big O of log n. So, this is the worst case complexity. In best case, this is worst case, in best case the complexity for this algorithm is big O of 1, because best case is what? At the middle, if we found the element, the first go, that is the best case, and in case of average case also big O of log n. And what is the auxiliary memory, or we can say extra memory space is used? No memory space is required for this case, and so the complexity is big O of 1 in case of auxiliary memory. Okay, thank you. If you have any queries, please write in the comment section.